Alright, today we're going to go over the Algebra 1 review flipbook for Algebra 2A. This is part 1. I think it's going to take more than one video. So we're going to start number 1 and we're going to see how far we're going to get. Alright. Now remember, for the solving portion, that's the first couple of pages, we're going to use PEMDAS in reverse. Alright, so you're going to go backwards to solve. Remember, addition and subtraction are going to undo each other. Multiplication and division are going to undo each other. Integral of an exponent, we haven't really talked about it, but we'll use radical to have that happen. Now, the first thing you're going to do is you're going to want to get rid of any parentheses. Usually by using the distributive property. Number 2 is you're going to want to get all the x's on the same side. Then you're going to use PEMDAS in reverse. So PEMDAS backwards to get the x equals some sort of number. And that's what we're going to do. Alright, so the first thing I'm going to do in number 1 is I'm going to get rid of the parentheses. So I'm going to get rid of it using the distributive property. Remember, 9 is a pizza delivery guy, so 9 is going to go over to 1 and turn into 9. 9 is going to go over to 2x and become minus 18x. Negative 3, same thing. Negative 3 times x, so it's going to be equal negative 3x minus 3. So I'm going to put all the x's on the same side. So what I'm going to do is I'm going to add 18x to both sides. I always move the smaller of the two. So negative 18x is smaller than negative 3x. Those will cancel. So look, the red writing is something I made up. That's why it shows up on both sides. All right, I made that up. So I get 9. I get 9 equals 18x minus 3x is going to be 15x minus 3. Now I get to use PEMDAS backwards. Remember, I'm trying to get the letter by itself. So I start at the bottom, and I say, do I see any subtraction? I do. Since I see subtraction, I'm going to get rid of it using addition. So that's why I add 3 to both sides. So remember, the red writing is what I created. I chose to add 3 into the right side. It wasn't part of the original problem. That's why I had to add it to the left side to keep it balanced. So now I have 12 equals 15x. And once again, I have to go through my PEMDAS backwards. All right, the subtraction's gone. There is no addition. There's no division. There's multiplication. How do I get rid of multiplication? By dividing. So I divide both sides. Now make sure you do the number in front of the x. So I divide by 15 on both sides. So x is going to be equal to 12 over 15, which is a really fancy way to say x equals 4/5. That's simplifying the fraction. So x equals 4/5. You could also put 0.8, that's fine as well. Alright, number 2 is very similar to number 1. So the first thing I'm going to do is make the parentheses go away. So I'm going to get rid of this negative 3/4. If you're struggling with multiplying fractions by a number, you can just use a calculator. 3/4 of 16, so negative 3/4 times 16 is going to become negative 12x. Negative 3/4 times 8 is going to become minus 6. Now with this part, remember, there's a negative 1 here. That's the pizza delivery guy. 19 is not the pizza delivery guy, so 19 is just kind of hanging out. We have minus 10x, minus 3. Now I'm going to put 19 and negative 3 together, and they're going to turn into just 16. And now I'm going to put my letters on the same side. So I'm going to add 12x's to both sides. See, this is the part I added up, so that's why it's on both sides. I chose to make 12x show up. It was not part of the original problem. Even though it's kind of like negative 12x, it's not part of the original problem. So then I have negative 6 equals 2x minus 16. Now I'm going to use PEMDAS in reverse. So now that I have one x, remember, now that I have one variable, I'm allowed to use PEMDAS in reverse. There's subtraction, that's why I add 16 to both sides. I get 10 equals 2x Alright, subtraction is gone. There is no addition. There's no division. There's multiplication. That's why I divide by 2. I get x equals 5. And like I said, if you want to check your work, you can always plug that 5 back into the original problem, and it should make two numbers that equal each other. Alright, so number 3, a little bit different. It's actually very, very similar, though. And the first thing that usually throws people off is this fraction. So the first thing I'm going to do is I'm going to multiply by 2 to make the fraction go away. If I do it on one side, I have to do the other. So the reason I picked 2 is because I see a 2 here, and if I multiply by 2, the fractions cancel. So I could have picked whatever number I wanted, as long as I did to both sides, but 2 makes the fraction go away. So the left side just turns into 5x minus 18. And I'm going to distribute that negative sign. Make sure you take the negative to both, so it becomes minus x minus 9 equals 6 minus 8x. That's because I distributed the 2 like a pizza delivery guy. Now on the left side, I'm going to combine my like terms. 5x minus x becomes 4x. I'm going to do negative 18 and negative 9 to get minus 27. And I get 6 minus 8x. Now, I'm going to put my letters on the same side, so I move the smallest x, which means I'm going to add 8x. Remember, I made this up. This is my part that I made up, so I have to write it on the other side. Because whatever you do to one side, you have to do the other. So that's the balance being part of it. 4x plus 8x is going to be 12x minus 27 equals 6. Now that I have one letter, I can finally use PEMDAS backwards. So I see subtraction. That's why I add 27 to both sides. I get 12x equals 33. And now there is no subtraction, there's no addition, there's no division, but there's multiplication. That's why I divide by 12. So my answer is x equals 33 over 12. Now that's not the best answer because 33 over 12 can be simplified into 11 over 4. Alright, so the first thing I'm going to do for number 4 is I'm going to cross multiply. I'm allowed to do this. It's just a shortcut to multiply, because I would multiply both sides by 7 and then both sides by 3. It's just a shortcut to make the fractions go away right away. So I'm going to cross multiply. So I'm going to have 3 parentheses 4x plus 1 equals 7 parentheses 2x minus 1. Now it looks just like the first problem where you have to distribute the 3 and the 7. So I get 12x plus 3 equals 14x minus 7. I have to put all my letters on the same side, so I'm going to move the smaller one. So look, that's a positive 12x. That's why I subtract 12x. Remember, this is the one that I made up. It's really close to what was in the problem, but I made it go up because it makes that go away. I get 3 equals 2x minus 7. Now I have to add 7 to both sides. I get 2x equals 10. Divide by 2 on both sides. X equals 5. Final answer. All right, for number 5, we're going to need to know some things. We're going to know that if you have matching bases, you're going to add the exponents if they're next to each other. If they're on top of each other, you're going to subtract the exponents. If you have a power to a power, you're going to multiply those two exponents. And if you have multiple things inside parentheses, the exponent will act kind of like the distributive property of exponents, where the exponent affects everything in there, even if that's a number. Even if that's a number, the exponent affects that. We should also know that any negative exponent will be put to the opposite side of the fraction to make that exponent positive, and anything to the 0 power is automatically 1. All right, so that's all the stuff you're going to need for 5 through whatever. All right, so this one right here has variables next to each other. So if you want, you can move it around like this, because it's all multiplication, and multiplication is commutative. And that looks like a property we have, which is add the exponents. So I do negative 5 times negative 4 to get negative 20. X to the third, x to the fourth is x to the seventh. Best answer right there. All right, number 6, very similar to number 5, except it's also got these parentheses going on. So the first thing I'm going to do is that 2 is going to distribute everything. Don't forget that it goes to the first 2 as well. So it's negative 2. And make sure you put that in parentheses so you don't make a sign mistake. I'm going to multiply 2 times 3 to get m to the 6th. If you don't know that n has a 1, that's why 2 times 1 is 2, so it's n squared. Now 7 mn to the fourth. Negative 2 squared is positive 4. And now I'm going to put the m's together, so it's times m to the 6th times m to the first, that's a little 1 there, times n squared times n to the 4th. And then I'm going to put the 7 up here. So I get 28 m to the 7, n to the 6. Final answer. Alright, with number 7 we have multiplication, division, and subtraction separated into 2. So you kind of have to think of these as two separate problems. So you can't do anything in between the two, but you can do them separately. So I'm going to look at the division part first. I'm going to do 52 divided by 4. So I'm just focusing on the numbers here. 52 divided by 4, that's going to give me 13. C12 over C2. Remember, you're going to subtract those exponents, so that's why it becomes C to the 10th. Now these are next to each other, so the two C's come together. I get minus 2 times minus 4, or minus 2 times 4 is minus 8, and C to the 10th. Since the exponents and variable are the same, they are like terms. So I get to say 13 minus 8, I end up with 5c to the 10th as my final answer. Alright, so number 8, there's a bunch of different ways to do this. What I'm going to do first is I'm just going to focus on the top first. I'm going to look at the top. I'm going to turn that into 20w to the third all over 24w8. So now I'm going to break this up into 20 over 24, which is just a fraction, times w cubed over w8. Now w cubed over w8 turns into w to the negative fifth. So remember, whenever you see a negative exponent, that just moves this down to the bottom. So w to the negative fifth would be up with 20, but when I want to change it to positive, it's going to go to the bottom of the fraction. Now I'm going to change 20 into 24 all over, it's going to become 5 6. So it's going to become 5 6, and this w goes down to the bottom, but it makes it positive. So 5 over 6w to the fifth. So 5 over 6 w to the fifth. Alright, so number 9 is very similar. Remember, this minus sign in the middle separates the two. So the only way I can combine the two is if they are like terms. So I'm going to focus on the first part, which I can do with parentheses. So the 6 is going to distribute to all these. So I'm negative 3 to the 6th, a to the 12th, b to the 18th. Now remember, that negative 3 to the 6 should be in parentheses, so you don't get a sign mistake. Notice, my variables are going to match, so I know I'm going to have like terms. So I end up with negative 3 to the 6th, which is 729. A to the 12th, b to the 18th, minus 25, a to the 12th, b to the 18th. Since they are like terms, I just combine the numbers. 729 minus 25, I end up with 704, a to the 12th, b to the 18th. And that's it for number 9. Alright, so what we're going to do first is we're going to distribute the 2 to the 9 and the negative 4, so it becomes 9 squared m to the negative 8 times 1/3 m to the 6th. 9 squared is 81, m to the negative 8th times 1/3 m to the 6th. I don't like how I wrote that. Now I'm going to put the m's together to get negative 2. 81 times 1/3 is going to be 27. So m to the negative 2, because I did negative 8 plus 6 to get negative 2. Now remember, what I say is if you have a negative exponent, it's like if you didn't pay your rent. So if you don't pay your rent, you have to go live in mom's basement. So 27 stays on top because he paid his rent, but m didn't. That's why he goes downstairs, and it makes it positive. Your final answer should be 27 over m squared. Alright, there's a bunch of different ways to do this. What I would do first for number 11 is I would take the little 3 to the top and the bottom of this fraction. So it becomes 4x to the 5th all over x squared times x to the 3rd all over x to the 6th. Now I would just make this one fraction bar, and I would have 4x to the 8th all over x to the 8th. So I combined the two. They were next to each other, so I added. Look, x to the 8 over x to the 8th, Those cancel, so you're left with just 4. Not x, 4x, just 4, because x, when they cancel, really becomes x to the 0, which is 1. So that's why this is gone. All right, that's it for 11. Now, on number 12, we're going to be using this list of numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, and so forth and so forth. We're also going to remember that the first rule is you cannot have a perfect square factor in the radical. And that's just a really fancy way to say if any of these numbers on this list right here, if any of those numbers divide into the number inside the radical, you're not done yet. The other rule is you're not allowed to have a radical in the bottom. Alright? So that's where we're at. Alright, so number 12 is square root of 49. If you go back to your list, 49 is on the list. So that means I can rewrite square root of 49 as the square root of 7 squared, which means the radical and the 7 cancel. So your final answer is just 7. 13, we have the square root of 361. Maybe you don't know that. If you do know it, you check it out, it's going to be 19 squared is 361, so those cancel, are just 19, or you could have thrown it into your calculator. Alright, so number 14, we're allowed to take, when you have a fraction inside the radical, you're allowed to take the radical to the top and the radical to the bottom. This works out really nicely because both 1 and 16 are perfect, so it becomes 1 over 4, which is just 1/4, and that's your final answer for 14. Alright, 15 is the square root of 80. So, once again, we're going to have this list of numbers. 80 is not perfect. If I go back to my list, 80 is not on there. 80 would go right here, but it's not there. So I'm going to start dividing. 64 does not go into it evenly. It's a decimal, 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 decimal. 16 is the first one that goes into that one evenly. Alright, so that means that's the one I'm going to use. So I'm going to say 80 is 16 times 5. So the square root of 80 is the same thing as the square root of 16 times 5. 16 is perfect, so he gets to leave jail. He turns into, the square root of 16 is 4. 5 stays in jail forever. That's it. 16, we have 2 square roots of 360. Same thing, 360, not a perfect square. But I can rewrite it as 36 times 10. 36 a perfect square. So this 2 is still hanging out. This 36 right here turns into 6 right there. This 10 stays in jail forever. Final answer is 12 square roots of 10. That's it for 16. Alright, so the square root of 243. Once again, 243, not perfect. But I can break it down as 81 times 3. 81 is perfect. So 81 turns into 9, because the square root of 81 is 9, and 3 stays in jail forever. And that's your final answer for 17. So once again, number 18, 384, not perfect. But 64 times 6 is 384. So I use my list of perfect numbers, and 64 is the biggest number on the list. So this 64 turns into 8, so I have 4 times 8 square roots of 6. So I end up with 32 square roots of 6. And that's it for 18. Alright, so number 19 is you have 2 radicals. I don't know what to do with 2 radicals, but because there's multiplication, I get to take those 2 numbers inside the jail and multiply them together and to get radical 180. Now I'm going to use my list of numbers. So I'm going to be looking for perfect numbers that go into 180. Alright? So I'm going to use this list for 180. The biggest number that I end up finding is 36, because 36 times 5 is 180. So I get the square root of 36 times 5. Well, 36 gets to leave jail. He turns into 6. 5 stays in jail forever. And that's it for 19. 20 is very similar to 9 and 10, except there's guys inside of jail and outside of jail. So 3 and 5 are outside of jail. 8 and 50 are inside of jail. So I'm going to multiply right away just to make things smaller. It's not the only way to do it. So I'm going to get 15 square roots of 400. Now, if you happen to look on your list or just happen to plug that in your calculator to check, this actually turns into 20. 400 is perfect. So since it's perfect, the GL goes away completely. 15 times 20 is 300. And that's it for 20. So number 21, we have radical 112 over radical 4. And I'm just going to plug that into my calculator, and I'm going to get 10.2. Alright, number 22, I have 6 radical 120 over radical 15. What I'm going to do, if I'm going to put 6, and I'm going to put those radicals together. So I'm going to do 120 over 15. The reason I do that is because that divides nicely. So it becomes the 6 square roots of 8. Now look, 8's not perfect, but 4 times 2 is equal to 8. 4 is perfect. So this 4 right here turns into this 2 right here. This 2 right here, he goes and stays in jail forever. So I end up with 12 square roots of 2. And that's your final answer for 22. Remember, no decimals. Alright, 23, radical 3 over radical 8. Remember, you're not allowed to have a radical on the bottom. So what I'm going to do is I'm going to create a fraction. That fraction has to be equal to 1. So I'm going to take whatever is here and I'm going to copy it. I'm going to copy radical 8 because I'm going to write it again. Then I'm going to copy it again on top. Because if the top and bottom match, it becomes equal to 1. So I multiply across the top to get radical 24. I multiply across the bottom to get radical 64. So this becomes the square root of 24 all over 8. Now remember, 4 is not perfect, but 4 times 6 is equal to 24. This 4 is perfect. It turns into 2. So we have 2 radical 6 all over 8. Now, that is 2 over 8, which is the same as 1/4. So 2 over 8 simplifies down to 1/4. So your final answer for this one is radical 6 over 4. It's the best answer for 23. Alright, so we have radical 10 plus radical 10. So since they are the same exact radical, you can combine them. Just like terms. So that's a 1, and that's a 1. That means we have 1 plus 1 is 2, so it's 2 radical 10. Done. That's it for 24. So the radicals must be exactly the same. So I have to hope that they can be broken down and match because of this plus sign in the middle. So I'm going to look at 50. 50 is not perfect, but 25 times 2 is 50. This 25 is perfect, turns into 5. So I have 3 times 5, radical 2. 98 is not perfect, but 49 times 2 is, so I get plus 7, radical 2. Now remember, 3 times 5 turns into 15. 15 plus 7, I end up with 22, radical 2. I'm allowed to add those numbers in front of the radical together because they're the exact same radical. So I end up with 22, radical 2. Alright, so I got radical 63 plus 4 radical 20 minus radical 7. So the first thing I do is I have to see if the radicals will match. So that's 9 times 7. 9's perfect, so this becomes 3 radical 7. This is 4 times 5. So that becomes, this 4 turns into a 2. That 2 multiplies by that 4, so it becomes plus 8 radical 5 minus radical 7. Only the radical 7's can be combined because they're the only ones that are like terms. So those two can be combined. If I have 3 radical 7's and I take away radical 7, 3 minus 1 is 2, so it's 2 radical 7. And I just add the 8 radical 5 next to it. And that's it for 26. For 27, 28, and 29, the only thing you're going to be using a little bit different is instead of the square list, you're going to be using the cube list. So that just means they're perfect cubes. So here's the list you would need for that. So 2 cubed is 2 times 2 times 2, which is 8. 3 times 3 is 9, plus times another 3 is 27. 4 times 4 is 16, times another 4 is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343, I believe. And 8 cubed is 512. So 27, we have the cube root of 8. So look, 8's on my list. That means this is a perfect cube, so you can rewrite it as the cube root of 2 cubed. The little 3's cancel. Your final answer is 2. 28, we have the cube root of 125. So that's the cube root of 5 cubed, which is just 5. Final one we're going to do for this, for the first half of the flipbook is, now 29 looks kind of complicated, but the first thing I'm going to do is I'm going to take my radical to the top. Remember, that's a cube root because this is called the index, which makes it a cube root. It just tells you to look at the perfect cube list. When I find out that 27 is on there and 512 is on there, so this becomes 3 8. So that's it. That finishes this. So that finishes our Algebra 1 Review Flipbook. Part 1 is 1 to 28.